Hello, dear learners. Today I welcome you for lesson 1 of chapter 2, that is kinematics. Here is the contact information. If you face any difficulty, you can contact me. So, the learning outcomes of today's lesson are that you should be able to understand and distinguish between scalar and vector quantities. You should be able to differentiate between distance and displacement. The content which we are going to cover in this lesson are scalar quantities, then vector quantities, distance versus displacement, and then you have practice questions as well. Scalar quantities. Previously in chapter 1, that was of measurement, we have discussed about physical quantities. Let's recall about physical quantities. Physical quantity is a quantity that can be measured, and the quantity that can be measured, it consists of numerical magnitude and a unit. And for example, length, you can measure its numerical magnitude, and once you measure the numerical magnitude, you also include unit with it. For example, length of a table is 5 meter. 5 is your numerical magnitude and meter is the unit of length. In the same way, mass is also a physical quantity and speed is also a physical quantity. So, scalar quantities. Scalar quantities are those quantities, are basically the physical quantities, are those physical quantities that have magnitude only. In this, you are not having any direction. You will only have numerical magnitude. Such quantities are known as scalar quantities. For example, distance or length. We only say that the length of the table is 5 meter. We don't say that in which direction the length or the distance is. In the same way, when we say that the mass of the body is this much, we don't say that in which direction the mass is, because such quantities are only having the magnitude. So distance, mass, time, speed and temperature are the examples of scalar quantities. Here you can see mass is a physical quantity, and mass of a gold bar is given, that is 1 kg. Only numerical magnitude is here. So it is physical quantity. This physical quantity is your scalar quantity. No direction is given here. Time, in time you are not having the direction. You never say that the time is 12.76 seconds towards east or west direction. No, we always say that the time is this much second, this much hours, this much minutes. So time is a physical quantity, and how much magnitude it is having here in example 12.76 seconds. So time is a physical quantity and it is also known as scalar quantity because time is not having any direction. Temperature is also having only magnitude. We never say that temperature is moving towards any direction. No, temperature is only having the magnitude. So such physical quantities which only have magnitude and no direction, they are not having any direction, such quantities are known as scalar quantities. Vector quantities. Vector quantities are those physical quantities that have magnitude and direction. In scalar quantities we have only magnitude, but in vector quantities we have magnitude as well as direction. Such quantities are known as vector quantities. For example, displacement, force, velocity and acceleration. There are so many other examples of vector quantities. So here is given one compass which can give an idea that direction can be north, east, northeast, south, west and so many other directions can be occurred in this compass. So here is one example that displacement from USA to China is approximately 11,600 kilometer. So distance is given between USA and China, and it is 11,600 kilometer. So it is magnitude, and in which direction China is. It's in the direction of east. USA is having China in its east. East is in this way, in this direction. So China is located in the east of USA. So direction is here, magnitude is here. This physical quantity is your vector quantity. So what is displacement? We will see in upcoming slides. In the same way, one more example I have. Two boys, Tim and Tom, are applying force to this box, to this cart. Tom is applying some force. For example, Tom is applying 5 Newton force towards west direction. You can see this arrowhead line is towards west direction, in this direction on the left hand side. And Tim is also applying some force in the direction of east. So force is having magnitude and direction, so it is your vector quantity. Velocity is also a vector quantity, acceleration is also a vector quantity. In the next lesson you will see that how velocity and acceleration are vector quantities. Distance versus displacement. So what is distance? The total length or path covered by a moving object regardless of the direction of motion. In this direction of motion we are not going to consider that. We will only consider that how much path is covered by the moving object, or what is the total length the object has covered from one point to another. That length or the path which is covered is known as distance. In other words, distance is the magnitude between 2 points. For example, distance traveled by the moving object from A to B. From A to B, path 1 is 13 kilometer and path 2 which is covered is 9 kilometer. Here is point A, here is point B, and object is moving some distance, is going to cover some distance. When the object is following this path 1, the distance is 13 kilometer. When path 2 is followed, the distance is 9 kilometer. So if you see here, we are not considering the direction of motion because direction is varying here. So direction we are not going to consider here. Only the magnitude is going to be considered here, and that magnitude will tell that how much path is covered by the object from one point to another. It is your distance. Displacement. The distance or length measured in a straight line. In a straight line. So the distance which is measured in a straight line in a specified direction, that is your displacement. So here you can see that from point A to point B we have path 2. This blue line is indicating path 2 and it is in a straight line. From A to B the distance is 5 kilometer. Displacement of the object from A to B is 5 kilometer, and it is towards the direction of northeast of A. A is here, east is in this direction. Here we have north, so this B point is in between north and east, so it is northeast of A regardless of the actual path this was. So we have here 5 kilometer displacement, that this point B is displaced 5 kilometer apart from A towards northeast direction. Here you have magnitude and direction, so it is your displacement. So here we have some comparison between the distance and displacement. Distance is a scalar quantity because it has only magnitude, whereas displacement is a vector quantity because it has both magnitude and direction, and the SI unit for both distance and displacement is meter. So you can see here in the example here that this red line is not your displacement, it will be your distance because it is not in a straight line. Same is the case with this green line. It is the path which is covered from home to school. Suppose one day you follow this path, this red path, and how much distance is this? You can say that distance is sum of total movement. You move from your home and cover some distance, that is 2 kilometer, then you take some this curved path, that is 3 kilometer, and then again you move some distance in a straight line, that is 2 kilometer. Sum of these distances is going to give you total distance. 2 plus 3 5, 5 plus 2 7 kilometer is the distance if you follow this red path. If you follow this green path, then you have traveled when you have traveled some distance from your home, it is 2 kilometer, then again 2 kilometer to some direction, 5 kilometer and 4 kilometer. So sum of this is 9 plus 2 11, 13 kilometer. So when you follow this path, this is a longer path. And when you talk about displacement, when you move from your home in a straight line towards your school, that will be known as displacement. And the displacement having the magnitude, that is 7 kilometer, and direction is also here, which you can uh, measure that in which direction it is. It is in the direction of southwest, northwest, sorry, northwest. North is in this way, and here we have west. So in between this, north and west, we have northwest direction. So here are the practice questions. In your notebook, you have to do the question that you have to mention 4 examples of each, that is scalar and vector quantities. You can drop your answer in comment section as well. So you have to tell 4 examples for scalar quantity and 4 examples for vector quantities. Question 2 is Chris walked 200 yards to Cherry's house. He left Cherry's house and walked 50 yards. 200, and then again he starts moving towards some way, and he covered the distance, that is 50 yards, to the store. After leaving the store, he walked to the same path home. And here is the home which is discussed is only he left Cherry's house, not here it is mentioned that Chris house, no, Cherry's house. So what was the total distance traveled by Chris? So you have to tell here what is the total distance which Chris has covered. Chris walked 200 yards to Cherry's house. He left Cherry's house and walked 50 yards to the store. After leaving the store, he walked the same path home. What was the total displacement? So here direction is not given to you. So think about this, that will be there any displacement? If so, what was that total displacement? Question 4. Stephen wakes up every morning to run. He runs up the street 12 blocks north. In this direction we have north. He turns around, runs 8 blocks south. So he takes a turn and runs 8 blocks south to a local store to pick up his morning sausage and biscuit. Calculate his displacement and distance up to the store. So all these 4 questions are for you. You have to do the practice. If you have any question, you can drop your question in the comment section. Thank you so much. Do not forget to hit the like button and to subscribe my channel.